Okay, as promised guys, I said I was also going to record for you how we would investigate how pH affects the rate of an enzyme control reaction. And the easiest one to do this with is with starch and amylase. Now, as you can see here on my sheet, I've already done pH 3 and pH 10. Okay, and you can see that I have some little drops here of iodine on my little spotting tile sheet. Now what I do, okay, for each of the 3 and the 10 that I've already done, okay, I am investigating different pHs. So I have some pH buffers. I have pH 10 here, pH 3, and I have pH 7. Now these solutions, oh, can't see that, these solutions contain, for example, an acid, an alkali, and obviously something that is neutral. And that is what I'm adding my enzyme to. Now, the best source of amylase, okay, that works really well is in fact in your saliva, okay? So I have a little jar here of saliva. That's not all saliva, there was water that I have spat into, okay, and mixed it up a little bit and just let it sit for a while. Now, if we were doing this in class, we would only be able to do this individually due to health and safety regulations from COVID. Okay, we don't want to pass any unnecessary microorganisms or pathogens between us, so we would have to do this individually. We would not be able to share or swap spit, shall we say. There's some negative connotations to that back in my day. So we are not allowed to use each other's saliva. Okay, and this is also why I didn't want to do it in lesson, because too big a risk with a big class. Okay, so essentially I have put on my spotting tile iodine, because my iodine is what is going to react with my starch if it's present. Okay, so you can see here that I still have starch present in these little, or in my solution, because my iodine has turned blue-black. Okay, so I'm going to add 1 ml of, so I've still got to do the 7 one, so I'm going to add 1 ml of my solution to my pH 7. And mix up a little bit. Okay. I'm just going to mix it a bit to make sure it's all mixed up. So I'm not just getting saliva. Okay. And then I'm going to add 1 ml of starch. And as soon as I do that, I want to start my stop clock, and I want to take a drop and I want to add it here. That's my 0 value. You can tell there's spit in it, but it's gross. There's still some starch in there. Okay, at 30 seconds, which is now, I'm going to take another drop. Okay. Well, this has worked really well, because there's a little bit of starch present in the first one, you can see. Okay, none in the next one. We'll do another one just to be sure. Yep. No starch present after a minute. Okay. At pH neutrals. That's a very quick reaction. Okay. So, when you're talking about how pH affects the rate of an enzyme control reaction, you will get a very different graph. So with your temperature graph, you'll get a slight curve up, top peak, and then a slow curve down after the enzyme denatures. With pH, it is it's a very narrow range, okay? Because any pH deviation of slightly above or below the optimum pH will cause the enzyme to denature, and therefore it doesn't work. Non-functioning, okay, didn't work after 5 minutes. Non-functioning, didn't work after 5 minutes, okay. There was still starch present here at 0, okay, and then no starch, okay, so very quick reaction here, okay. If you would like more information on how pH affects the rate of an enzyme controlled reaction, okay, please use your textbook to do some extra research, and if you still are confused, please come and see me.